Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P1116, indicates an ECT, Engine Coolant Temperature, Sensor 1, range or performance problem in the Honda CRV models from 2011 to 2016. This code is generated when the Powertrain Control Module, PCM, identifies that the data being received from the ECT Sensor 1 falls outside the expected range for normal operation, or its performance is inconsistent with the specified parameters. The ECT sensor is crucial for relaying the temperature of the engine coolant to the PCM. This information is used to regulate fuel injection, ignition timing, and ensures optimal performance of the vehicle. Located typically near the thermostat housing, the ECT sensor measures the coolant temperature so that the engine can achieve the correct operating temperature efficiently. If this code appears, it is recommended to systematically determine the root cause through a series of predefined troubleshooting steps. The DTC P1116 highlights a performance or range problem with the ECT Sensor 1 circuit. The ECT sensor has a critical role in monitoring the engine's coolant temperature. This sensor measures the coolant's temperature and sends this information to the PCM. Typically situated near the thermostat housing, it allows the engine to switch to optimal functioning parameters based on real-time data. A fault in this sensor can cause engine performance issues, as the PCM relies on this vital information to make adjustments to fuel delivery and engine timing. When the temperature readings from ECT Sensor 1 deviate from expected values, it triggers the Diagnostic Trouble Code P1116. Several possible causes can lead to the activation of DTC P1116. One common reason is poor electrical connections or loose terminals, which may disrupt the signals being transmitted from the ECT sensor to the PCM. Additionally, if the ECT Sensor 1 itself is faulty due to wear or internal malfunctions, this will trigger the code as well. It is also possible that issues with ECT Sensor 2 could affect the performance of ECT Sensor 1, especially if both errors appear simultaneously. Lastly, there might be problems with the PCM itself that cause incorrect interpretations of the ECT sensor readings, thus necessitating thorough troubleshooting to pinpoint the actual issue. When DTC P1116 is triggered, several symptoms may present themselves, indicating a potential issue with engine operation. One common effect is increased fuel consumption due to the PCM not receiving accurate temperature data, leading to incorrect fuel delivery adjustments. Drivers may also notice engine overheating, as the PCM cannot optimally manage the coolant temperature, affecting overall engine health. Poor engine performance is another symptom, as the engine may struggle to run efficiently without correct temperature readings. Lastly, the most obvious symptom for most drivers will be the illumination of the check engine light on the dashboard, alerting the driver to potential issues that need to be addressed. The initial troubleshooting step for diagnosing DTC P1116 requires a thorough visual inspection of the connectors and terminals related to the ECT Sensor 1 and ECT Sensor 2. This includes checking for any poor connections, corrosion, or loose terminals that could disrupt electrical signals. These sensors are critical components, located primarily near the thermostat housing, where coolant passes through. By ensuring the connections are intact and securely fastened, mechanics can determine if this is the root cause of the issue. If connections appear satisfactory, the troubleshooting progresses to the next step. If not, repairs should be made to restore integrity, and then the repair verification should be performed. The next step involves checking the Powertrain Control Module using a Honda Diagnostic System, HDS. Begin by turning the ignition switch to the on position. labeled as Position 2. This action powers up the vehicle's electronic systems without starting the engine. Once in this position, you can check for any pending or confirmed DTCs that the PCM may have registered. It is essential to specifically look for both DTC P1116 and DTC P2183 being indicated together. Since if both codes are present, a different troubleshooting path begins. If only P1116 is indicated, the diagnostic process moves to the next relevant step, addressing just that specific code. In this third step of troubleshooting, the first focus is on performing a performance check on ECT sensor 1. Start by allowing the engine to idle for a full 10 minutes, which helps stabilize the temperature readings for accurate assessment. After this period, connect to the Honda diagnostic system to check specific parameters of ECT sensor 1 against established thresholds. It is critical to ensure that the current conditions reported by the HDS match expected values. For example, ECT sensor 1 should indicate temperatures less than 108 degrees Fahrenheit, 42 degrees Celsius. If the sensor readings meet this threshold, the next course of action is to replace ECT sensor 1 and proceed to repair verification. If the conditions do not match, this indicates that the sensor is functioning correctly, leading to further steps. This step verifies potential problems by allowing ECT sensor 1 to cool down to the ambient temperature, ensuring accurate readings for further diagnostics. Begin by turning the ignition switch to the lock position, allowing the sensor to cool completely. It is also important to note the ambient temperature for reference. After these preparations, turn the ignition back to the on position while rapidly checking the ECT sensor 1 values displayed on the HDS. The next task is to compare the displayed value against the ambient temperature recorded earlier. If the reading from ECT sensor 1 deviates by more than 5.4 degrees Fahrenheit, 3 degrees Celsius, replacing the sensor becomes necessary, shifting back to the repair verification phase. If it shows no significant difference, intermittent failure must be documented, and a check should continue for possible weak connections or issues elsewhere in the system. Step 5 involves another performance verification procedure for ECT sensor 1. Begin by starting the engine and allowing it to idle for another 10 minutes, which helps achieve stable conditions. During this period, use the HDS to check the ECT sensor 1 values again. The comparison here is crucial, as the current sensor readings must still be below the threshold of less than 108 degrees Fahrenheit, 42 degrees Celsius. If the sensor values are acceptable and within limits during this check, then replacement of the ECT sensor 1 should be undertaken, followed by confirmation of successful repair procedures. If the performance does not match expectations, transitioning to the next troubleshooting step is required. Following the performance check on ECT sensor 1, the next step focuses on ECT sensor 2. Start the engine again, letting it idle for a full 10 minutes to stabilize the temperature readings for better accuracy. Using the HDS, check the current parameters of ECT sensor 2, paying close attention to the specified thresholds. As with ECT sensor 1, values need to be below 108 degrees Fahrenheit or 42 degrees Celsius for proper functionality. If ECT sensor 2 indeed falls short of the required threshold, the recommendation is to replace that sensor, similar to prior steps, then complete the repair verification. If not, this leads to another round of diagnostics to ensure the system's integrity. The final troubleshooting step involves comparing the values of both ECT sensor 1 and ECT sensor 2 after they have cooled to ambient temperature conditions. Start by turning the ignition to the lock position to allow the sensors adequate time to cool. The next action is to switch back to the on position to check values from both sensors as displayed on the HDS. Each sensor's current value must then be compared to the ambient temperature previously noted. If either ECT sensor 1 or ECT sensor 2 shows a significant deviation of more than 5.4 degrees Fahrenheit, 3 degrees Celsius, from the ambient temperature, replacement of the affected sensor is warranted. If neither sensor shows significant variations, the conclusion is an intermittent failure, and once again, inspections for weak electrical connections are advised. After performing the necessary repairs based on earlier diagnostics, the final repair verification stage is crucial to ensure that corrections have been effective. Start this phase by turning the ignition switch to the on position, ensuring no engine start yet. Utilize the HDS to reset the powertrain control module, PCM, which clears out any memory DTCs resulting from prior issues. After this reset, an important part of the process is performing the PCM idle learn procedure, which helps the vehicle recalibrate its settings based on the new or repaired components. Finally, check the HDS once again for any pending or confirmed DTCs to determine whether the P1116 code still appears. If it does, further review of connections or other underlying issues will be necessary. Preventive maintenance can significantly reduce the occurrence of issues related to DTC P1116. Regular inspections of the ECT sensors are recommended to ensure they are functioning properly. Checking the electrical connectors for signs of wear, corrosion, or loose connections can help prevent improperly functioning sensors. Keeping a close eye on the overall engine performance and monitoring any fluctuations in coolant temperatures can also provide early warnings of potential problems. Routine diagnostics using the HDS can further identify any underlying electrical issues. Finally, maintaining consistent service intervals may help in early detection and correction of any problems, ensuring a healthy engine operation. In summary, DTC P1116 identifies a performance issue related to the ECT Sensor 1 in the Honda CRV models from 2011 to 2016. By understanding the function of the ECT sensor, technicians can effectively diagnose and address the root causes behind the reported issues. Following a structured troubleshooting approach ensures that the problem is identified systematically, avoiding any oversight. After repairs, it is essential to verify the effectiveness of the solution to prevent future occurrences of the code. Additionally, implementing preventive measures through regular inspections and maintenance practices plays an essential role in sustaining vehicle performance and reliability. These steps not only enhance the life of the vehicle, but contribute to safe and efficient operation on the road. Please like and subscribe to the channel. See you next time.